Hello, so I'm Kenton Robbins. Some of you know me, some of you probably wish you don't. I'm here to talk about infrastructure as code with Terraform. So first of all, just to get a rough idea of sort of who people are. Do we have any IT guys in the room? You two don't count. Do we have guys that use AWS? Does anyone use AWS here? Quite a few AWS. What about GCP, Google Cloud Platform? Any of those? Two? It's coming up. Azure? Anyone with Azure? A few more of those as well. Anything else? We'll see anything else.
I work for a platform on our own infrastructure as well.
Is that like an OpenStack sort of thing?
No, it's a platform that I take.
That's interesting. It's more for sort of my interest more than anything. It's not working. There we go. No.
Just turn it off now.
See, I'm completely stumbled by anything sort of technical.
Do you want me to?
Yeah, can you? So traditional infrastructure management. Who was developing in the days when we had to go out, source hardware, bring it in, provision it, sort it out, you know, that sort of stuff, look after it, fans blowing, replacing it. Yeah, frustrating, right? So this sort of stuff still goes on in a lot of places. You know, I'm not necessarily against it. I have things at home. I've had pieces at places where I work to be able to provision things and run things quickly and efficiently. However, you know, there are some sort of pitfalls to that sort of thing. You need people to come in and manage that sort of stuff. You've got the network coming in that you need to manage. You know, it can be quite costly. I don't need to sell cloud to you guys because, as you already said, a lot of you guys are already using cloud infrastructure. So move on to cloud infrastructure management. Right, so this kind of changed things in a bit. So initially when the cloud came out, and this was sort of my experience from the companies that I work with, it's where people tried to shift their existing hardware infrastructure over to the cloud wholesale and just keep it exactly as it was. So we've got one server that does this thing. We're going to lift that, shift that. We've got this thing on the cloud now. Okay, so a lot of people come into these things and they say, you know, cloud's not as cost efficient as they were selling it. Maybe because it wasn't sort of set up in the sort of way that cloud should be. And what I mean by that is that the cost savings with cloud are by structuring your infrastructure in a slightly different way. Does that make sense? I'm rambling a bit. It makes sense in my head. So we'll move on. So in terms of operational maturity, you've got your manual stuff, you've got on-prem servers, hosting, you've got an IT team that supports that. Semi-automated, which in my experience is where most people kind of sit. So that's where you've got some on-prem stuff, you may have some AWS stuff, branching out into that world and using things like infrastructure as code, if not using something like code deploy or, you know, a number of other tools. You've got the infrastructure as code, which is full infrastructure as code implementation, which is what we're going to talk about today. And then collaborative IaC, which is where you distribute that to your team and they can sort of look after that infrastructure and manage that. DevOps, which is basically where we are. So infrastructure as code, the management of infrastructure. So it's basically, yeah, the management of infrastructure as code. So you define what you want your infrastructure to be in code, and you can deploy that and roll it back when you need to. Let's go to the next. So Terraform, where does Terraform sit with this? So there's a number of tools that you can use to sort of achieve this infrastructure as code. But Terraform I've been using for a little while because it's cross-domain, it's lightweight, it's nice. I'll come back onto those points. Probably going to loop around a couple of times on those sort of things. But Terraform is essentially a tool that enables you to do this sort of thing. Provisioning workflow. So essentially how Terraform works is it's a three-stage sort of role. So when you think about your workflow, doing things, it's kind of outside the normal development scope, how you would normally sort of handle that sort of stuff. So initially it's the write stage. You go out and say if you've already got an existing infrastructure, you need to translate that into code, write that into Terraform code. The next stage is to plan, and in Terraform plan is when you can call the command Terraform plan and it will go off to your cloud services, your on-prem, whatever it is that you've got, and it will match up what your plan says against what your infrastructure is currently doing at that time. And it will say to you, you know, these changes need to be done to get you to the state where you are, which is ideal sort of in the early stages. If you're currently sort of taking this stuff on board, you can check to make sure that your plan matches up with what you've actually got. And then apply. Once you're happy with those changes, or whatever it may be, you apply. Terraform will go out, it will talk to AWS, GCP, Azure, whatever it is, make those changes, provision them, and then let you know when it's done. So what does it actually look like? So this is just a snippet of infrastructure, effectively. This is what this stuff kind of looks like now. I'll go into some more details about what some of these things mean. Providers, AWS, things like this. Yeah, we'll move on. So this is back to the planning space. Again, on your local machine there'll be a copy of the most recent state of where Terraform thinks that you are and where that you should be. It'll come off, match that stuff, and then come back. Next slide. And apply, which we've already covered. Okay, so what I want to talk about now is about Terraform providers. So this is how Terraform talks to your providers and, you know, is able to communicate with them. So there are a number of different sort of providers that act like dependencies for Terraform. So when you create your infrastructure, you can call Terraform init, and it will bring down all the code required necessary for it to be able to talk to AWS, GCP, Azure, and the other things. So we're going to go back into these things. So what I want to talk about now a bit, just to sort of demystify a couple of things, is what IaC is and what the others are. So infrastructure as a service. So we've talked about a couple of these. What's interesting for me is that, you know, as AWS still holds the majority of the market, but platforms like Azure and particularly Google are growing rapidly, the same with Alibaba Cloud. And the other market, that could be a whole bunch of different things, but what I think that probably is mostly is this OpenStack stuff. So a lot of people are hosting OpenStack where they've got existing infrastructure, so larger companies, and they've got all these servers left around. They're installing OpenStack and then providing their own cloud solutions that people can tap into. So platform as a service providers, does anyone recognize any of these, like Elastic Beanstalk? Does anyone use that? So these are just things that you can tap into to deploy your apps a lot quicker, things like Kubernetes, Docker, Firebase. SaaS providers. So these are things, like I said here, software as a service, which is great. And the reason why I'm telling you about these things, the next one, is because where infrastructure has traditionally been thought about, so networking, routers, servers, whatever else it is, there's a whole load of other things that are now sort of brought into that light and they're managed in a certain way, and you can do all of that with Terraform. So in terms of you can manage your GitHub accounts and stuff like that. If you use that sort of thing, you can send stuff off to Slack. You can bring in things like PayPal and link those up to other services as well, and you can define all of that infrastructure as code. So Terraform state. So yeah, as I've kind of covered already, I'll probably loop around a couple of times on some of these things. So Terraform state is a state file that defines what your infrastructure is, what basically for what your current system thinks it should be, and compares that to up on the cloud, what's actually going on at that time. That's always stored on your local machine. You can call things like Terraform refresh, which will go up and get that information and update that sort of stuff, and provide you with that single point of truth. But that's always stored with you as well. Right, so Terraform variables. So there's, in Terraform, there's a couple of different ways of, firstly, providing abstraction in the way that you provision stuff. So you can have a file containing a number of different resources, but there might come a time where you want to change the AWS region, for example. You're in US East or whatever, and you want to change it to West. What the best practice normally is to abstract that stuff away, have that to one side, have a variable set of folders, and you can change the properties and deploy it wherever you need to do. That's just variables within Terraform itself. Outside of that, you've got these input and output variables, and what they are is input variables allow you to send information to Terraform from the command line. So if you have like a shell script that you know that you want to run to deploy this stuff, you can pass information into that. So that provides an extra layer of abstraction. You can pass, if you could write a shell script for deploying dev servers or whatever, and you can plug that info. Output variables is kind of used for the same thing. Once it's done, it comes back and it sends you that information. It says, right, I'm done. This is what I've deployed, for example, and this is where it is. Here's an ID for X. Terraform modules. This is a way for you to create different parts of infrastructure and contain them in a separate way that you can include as kind of like dependencies. So again, that provides you with that level of abstraction. So moving on down the line, we'll talk about this again, because I've been circling a lot, probably going to keep doing that. What was I going to say? Yeah, so modules, what you can do is things like this, is say for example you've got a standard plan. If you want to deploy a Lambda, and you know that your Lambda is going to have an API gateway and it's going to be in security group X, whatever it is, you can provide templates for that can be signed off at a higher level, meaning that you can deploy that to other developers within your team that don't have that infrastructure knowledge, and that would enable them to provision that infrastructure without having to know everything about it. That makes sense? That's one of the uses for it. The other one is that you can have a whole collection of different things. If, for example, you can have a staging environment, you can store that in a module if you like, or a dev environment. Yeah, and include those as dependencies. We'll jump to the next one. Terraform Graph I've found quite useful, because one of the issues I've found working in a larger team that uses cloud infrastructure is that there's a lot of stuff in there and there's a lot of stuff going on, especially if you have dev, stage and live environments all in the same place. There's kind of things all over the place. There's Lambda functions, you've got EC2, you've got all the other bits that people have created. With Terraform, you can print out a graph like this. So it's actually quite simple to do. So in Terraform, you have a command Terraform graph. It will print you an object that just basically explains what this is. On the Mac, if anyone's used GraphViz, you can pipe that command into GraphViz and it will print you out an object just like this. So does anyone like writing documentation? No one likes writing documentation. It's terrible. All terrible people. So you can export something like this and you can chuck this up and say, like, this is the infrastructure. That's bare minimum. That's good, right? Because the thing that kind of frustrates me is when I start a new job and I'm like, okay, so how does everything work? How does it link together? And I get sort of a blank face or a, I know about this bit and he knows about this bit, and you're like, I just want to know how these things work. And something like this, straight off the bat, you can see what's going on. You can see how things are linked together. Jump into the next one. Okay, we'll do best practices. So yeah, make use of Terraform variables, absolutely. The input and output variables may be not as important for most people, but in terms of keeping domain-specific information away from the actual infrastructure itself, yeah, absolutely do that. The same as Terraform modules, again, provide that abstraction. There's nothing worse than a huge file with thousands of lines of code in it, and it's just one straight file. It's really frustrating. The other thing that's super important is keeping the connection details out of source control. So that's for your cloud infrastructure itself. So everyone's slightly different. So AWS will store on your local machine and you've got keys there to provision that stuff. That's fine. Google's are quite open, so you just want to make sure that you don't commit that stuff up to source control. But I shouldn't have to tell any of you guys that. You probably all know that already. Make good use of the git ignore, and this is just not just for Terraform. It's a bit of sort of a pet hate of mine when people commit projects into source control without git ignore files, and they've got all the npm modules and stuff like that, and you're like, why is this repo 4 gig? And it's because of that, and it's a simple fix. So please be kind. And have a human operator to review the plan. I was going to say always have a human operator, but the thing is, it's kind of like my vision that eventually you shouldn't have to have someone in the middle to be able to check this over before you commit those changes. I know at this stage, all of this stuff's kind of in its infancy, and we need to put policies in place, but those policies should be human-based policies, so you should commit to, they should be sort of code reviews, pull requests, all that sort of stuff that you would normally do with any other sort of code. before you get to the situation where you're going to actually deploy that stuff. So, yeah. Alternative solutions. So there's a number of different ways that you can achieve the same result. But for me, so I've used CloudFormation before, which is great. It's a nice graphical user interface for sort of managing that infrastructure. But it is domain specific. That is AWS, vendor locking, you're stuck there. The difference with Terraform is that obviously you can use it for any of these providers. There's also things like Ansible, Puppet, and Chef. They're all great solutions, but on balance, you know, we never really know where it's going to go. But yeah, I'd say Terraform's pretty great. Oh,
no. I've screwed it up.
Okay. So why Terraform then? So I kind of covered some of these things. You can use Terraform on its own to provision all of your infrastructure and all of your SaaS and all of your platforms. Or you can use it in conjunction with some of these other tools. So if you're already using things like CloudFormation or whatever, you can get Terraform to use those solutions as well to deploy that stuff. Terraform is super lightweight. There's not a whole lot of code that you need to write to provision some quite complex infrastructure. Cloud agnostic, as I said. There's kind of three flavors of Terraform. There's the open source one, which is the one that I use most of the time. You can contribute to that as well. If anyone writes Go in here, which I'm interested to know, does anyone write Go? Got any Go developers? We've got a Go developer too. Yeah, so if anyone wants to learn Go, or those guys may well help you, you can contribute and you can add extra plugins into Terraform to do different things for you. So if you've got specific things that Terraform doesn't currently do, you can write that yourself. There's a pro version and there's an enterprise version that's kind of paid for versions that add in some extra tools which are kind of handy. So they sort of manage things like secrets management and a couple of other bits. And it's very well documented. A lot of people are using it at the moment, which is a huge benefit. If you need to find out how to do something, it's already there. There's a bunch of stuff that Terraform have put out for us already in terms of templates for infrastructure. I know that AWS have a repo with a load of that stuff in as well, with sort of standard templates on how your infrastructure should be. So that just makes the whole thing a lot easier. Before we jump into the questions, I just want to cover a couple of bits that I didn't cover in the slides that I wrote on the description of what I was going to be talking about. So I just want to make sure I've covered everything. So saving money. Why does Terraform save you money? So one of the biggest things for me is that it's a team multiplier. And what I mean by that is that normally you've got a guy or a couple of guys or a team that manage infrastructure, and you have to go away to those teams and you have to get them to do that stuff. If you use Terraform the correct way and you make use of the modules and the variables, you can allow other developers to use that code to deploy infrastructure on their own. You know, it's always good to have someone there to sort of check things over, but it means that more people can go out and provision this stuff and get these things to market quicker. Quicker is cheaper. Right? And also easy scaling. So well, you guys know one of the biggest benefits of cloud computing is that you can scale nice and easily, but a lot of people are quite uncomfortable with using the auto-scaling features in cloud. I know, I've been quite nervous of it until sort of got a grip of the payment stuff. But with Terraform, what a lot of people use it for is that they'll know when their peak times are, and they have a Terraform plan for the peak time, and they have a Terraform plan for outside of time, so they can just deploy their infrastructure, scale it up at one point with one command, bring it down again with another command and replace it with something else. So again, that puts that person in charge of scaling, more control over the costs. The next thing is reducing risk. So again, with infrastructure, those things when you change them, it's not normally like deploying code where if something goes wrong, you should be able to roll that back quickly. If you've got your CI and CD probably working, that you can just roll those things back and deploy the old code. With Terraform, you can now do that sort of thing. So it's not like you've brought in the wrong hardware or whatever. It doesn't matter. You can just drop that infrastructure and recreate it with a command. Again, so back on sort of the process of managing infrastructure. So the kind of way that I see it is that once the infrastructure has been created, that would be sort of like a one-off effort where you put together this is what a Lambda function looks like to our company. this is how we deal with it, this is what the security policy should look like. And once those things are defined and signed off, you can hand those over to the guys and they can just play with those things. And then also easier rollback to the early version of the infrastructure. So because this is code, you can deploy it, you can store it in source control, and you can roll it back to older versions. It's like all those principles that we found with software engineering for the same thing for the infrastructure now. So we can manage it in that way. And I think that's mostly it. Has anyone got any questions? I can't possibly have said everything. Has anyone got a terrible joke?
Okay. Not a joke.
Here we go.
So again, I can see why Terraform over like AWS.
Yeah.
But why Terraform versus Ansible? Why Terraform versus Chef or something?
For me, it's more about the support in the community. That's the biggest thing. It seems to have the most, the biggest community supporting it. And from a developer perspective, when you're picking a tool, that's one of the things I look at first. So if I'm going to pick up a new library or something like that, it's like how many people are talking about this? What support can I get for free? And that's one of the biggest benefits for me, I'd say.
So no one's actually ever bought professional enterprises?
I don't. No, I haven't. I probably won't. But it's the same with all of these sort of things. They're open source initiatives, and there will be companies that will buy them just for the sake of it says enterprise. And I've been part of companies that will just buy enterprise versions, regardless of what you actually get for it. It's not for me. Okay. You want to swear at me? Thanks for your help, guys. Thank you very much.